Hi, hello children, welcome back to your favorite channel, that is Physics by Imagination. Dear children, in this class we are going to understand about light. Here we are going to get minimum 3 to 4 questions. So what is light? It is the form of energy which senses us to see the things. You are all seeing my video. I am all seeing the everything. Everybody sees everything because of light. So first point, laws of refraction. So what is refraction? You take a ball, throw it through the wall. When you throw it on the wall means what happens here? It comes back. That is, bouncing of ball is called reflection. Means similarly bouncing of light is called reflection. So what is refraction? Take a ball, throw it through the wall, throw it through the window, then ball will go from one medium to another medium. So that is called refraction. Means when we pass the light from rarer medium to denser medium and comes to again a rarer medium, that is called refraction of light. It means, very simple children, the process of bending of light from one medium to another medium and bends after moving to the denser medium, that is called refraction of light. Just the process of changing direction of the light when it moves from one medium to another medium is called refraction of light. Next, RTZ, refraction through glass slab. So here I will incident the light here, then the light will fall, then one ray will go to the straight way, one ray will be moved away from the refracted ray. Here very important point is going to be asked. The refracted ray will move straight, emergent will move away from that. So here what is refraction through glass slab means? Here the words will be slightly increased. Okay, so best example is Pierce soap. You can take and put on the words. Now here rarer medium, denser medium, rarer medium. When the light will fall here and refracts and changes direction and comes here, that is refracted ray, and this one is emergent ray. Due to these two rays, the words will be slightly magnified. So now very important point here, in the refraction we have two laws, that is the angle of incident to the angle of refraction is constant for given pair of media. It depends upon medium. You can take water medium, air medium, water medium, glass medium. Okay, and when it is moving from, very important, when it is moving from a rarer to denser medium which moves towards the normal ray. Okay, suppose you are running. Okay, if road is good, what happens? You can run very speedily. If road is mud means speed will decrease. Same thing here, because of more optical density present in the denser medium, so here which moves denser, that is towards the normal ray, because speed will reduce. Similarly, when the light will move from denser to rarer, so again mud road to normal road, speed will increase, so which moves away from the normal ray. So this is all about RTZ. Next, I told you first law, that is the ratio of sine of angle of incidence to the sine of angle of refraction is constant for given pair of media. Second law, very simple. This incident ray, normal ray, refracted ray will lie on the same plane. Means they all lie on the same plane. The incident ray, refracted ray and normal ray are all lie on the same plane. Over. Next, ray diagrams and rules. The children, we have three important rules here. Ray diagrams means what? Which indicates how the path of light will be moved. Now very simple. So this is convex lens and this is concave lens. If the lens in the middle thin means that is concave, edges thick means that is concave. Reverse, in the middle thick, edges thin means that is convex lens. So concave lens we are using to correct the myopia means we are seeing far distance not clearly. Again we are using in binocular. And convex, many uses are there. Used by palmist, okay, jewelry shop, to read small words, to correct hypermetropia. Different uses are there. Okay, watch repair maker. So now here you understood convex lens and concave lens and uses. So ray diagrams means here very simple rules. When light will come straight, it has to bend, it has to go under refraction, so that it will go under refraction. Means when the rays are coming parallel to the principal axis. Let us learn within 2 minutes about this. When light will pass, they will meet at one point, that is called principal focus. Number of light rays will meet after refraction at one point, that is called principal focus. And this is called optical center, center of the lens. And distance between O and F is called small f, focal length. Okay. Now this is object, this is image. So what is my point here? Rules. When it is moving parallel to the principal axis. Remember, principal axis is called undeviated ray. It doesn't go under refraction because angle of incident is equal to angle of refraction. Now it is moving like this. It has moved. So now what is my point here? Focal length means distance between optical center and principal focus. Principal focus means the number of light rays which falls under and they will meet at one point, principal focus. Yes, over. Now this is the first rule. Second one, a ray should passes through the optical center. Two rules are very, very important. Okay. Now let us understand by using two rules all diagrams. So here, object distance, image distance. The children, 100% damn sure you will ask easily. Let us learn within 3 minutes, 4 minutes. First one, when the object is at infinity, image will form at F. Okay, so here very simple. What is the meaning of RIP? Real inverted point size. What is real image? We can see the image and we can take on the screen photo. Okay, but we cannot take on the screen means that is virtual image. We can see but we can't take on the screen. So now here when the object is at infinity, image will be at F. So nature they will ask you children, that is RIP, real inverted point size. Next second ray diagram, beyond 2F. The children, if I keep beyond 2F, here we should take equidistant points. Then what is going to happen? That is going to form between F and 2F. Then image will be RID, that is real inverted diminished. Again reverse children, vice versa. If I keep object here between F and 2F, beyond 2F, image will be formed. Vice versa, that's it. Then nature of the image will be real inverted magnified rim. Okay. Next we come to the point at 2F. See, very easy. 2F means 2F. So we can write that RI means real inverted erected. Erected? No. That is real inverted equal in size, not equal in size, not erected. Next at F. See, vice versa. If object is at infinity, image will form at F. If object is at F, they will meet at infinity. They never and ever intersect. Last but not least, between O and F. See children, the special property of the convex lens is that when the object is far means it is going to form real inverted image. When the object is near means that is going to form virtual erected image. To see small words, when you keep near the words, the size will be increased. Okay. Now this is all about convex ray diagrams. Now here between O and F means behind the lens. Remaining all cases, images are formed right side when object kept left side. But here image and object will be formed at the same side. So that we can tell that this is called rim, real inverted highly magnified children. That is at F means highly magnified. So between F and O means that is meow. It means magnified erected virtual image. So very easily understood, I think. Thank you for that. And next concave lens means very easy children. When the object is at infinity, at F. Between F and O means this again between F and O. Concave is only two diagrams. Please go through that. Next, we have refractive index and power of a lens. So because these ray diagrams are difficulty. In concave, one is at F means infinity. Again, between infinity and O means it forms between O and F. Just easy diagrams. You can draw like this. Okay. And here, concave lens, the image and object will be the same side. That you should remember. Next, we come to the point refractive index and power of a lens. Very, very important. Many times they asked. You can easily expect the question here. So, refractive index. So, when the light is moving from one medium to another medium, which bends, that is called, the measurement of the refraction of the light is called refractive index. That is, it is given by formula. It is a simple meaning. The speed of light in medium of air and the speed of light in any medium. That is, this is Vm, this is Cv. Means when the speed of light in vacuum or air, the speed of light in any other medium, air medium, water medium, glass medium, etc. etc. So what is refractive index? The speed of light in one medium. That is, speed of light, it is the highest speed in the universe. If I blink once, in that time it is going to cover 3 lakhs kilometers per second. So, you understood this speed of light in one medium to another medium. So, here n is inversely proportional to v. So, if speed of light in the medium is less means refractive index is more. If refractive index is less means speed of light is more. Example, air, water, glass. Air is 1. Water is also 1. Okay. So now this is water about 1.33. Glass 1.5 nearly. Okay. Now here it means if I take that is glass, air, aluminium. Okay. So here which is having highest speed, lowest speed, you will ask. The children, if velocity of the medium, that light is less means refractive index is more. So now here that is glass, air. Air is having lowest optical density. So here speed will be more, hence refractive index will be less. And in the aluminium, it is a solid thing. So that here what is going to happen? Speed will be less, hence more refractive index. That's it. So unit, that is meter per second by meter per second. It doesn't have no unit. It is dimensionless physical quantity. Same thing come to the point. Power of a lens. So power of a lens means what? Very simple. It is ability of the lens either converge or diverge the light. Okay. It means this power of a lens is nothing but, we can discuss one more way, that is the power of a lens is nothing but it is reciprocal of focal length. What is focal length? The distance between a principal focus and optical center. Now, so here, if focal length is equal to 1 meter, it becomes 1 meter inverse. That is called 1 dioptre. Okay, very important. 1 dioptre means 1 meter inverse. So now here, again very important. How focal length and power of a lens are related to each other? That is inversely proportional. If focal length will decrease, power of the lens will increase. If focal length will increase, power of a lens will decrease. That's it. And remember, convex, concave, it is positive. In numericals also we will discuss. That I will tell you in the numerical part. Children, in this class only I will tell you after this class. So now convex, power of a lens is positive. Concave, that is negative. That's it. Now formulas. Very simple. This is called lens formula. 1 by f is equal to 1 by v minus 1 by u. What is f? That is called focal length. V, image distance. ID. U, object distance. By using this we can find focal length of the lens. Okay, last but not least, m is equal to v by u. To find magnification. So when we take the ratio of image distance to the object distance, which gives rise to magnification, means how much size of the image has been changed. So shortcut trick we can use to find focal length, because in exam we will be having less time. Principal focus is equal to, if you do LCM and simplify, means you get F is equal to V into U divided by V minus U. It means the product of image distance and object distance divided by difference between object distance and image distance. Dear children, did we leave anything? Yes, loss of refraction over, light over, RTC over, ray diagrams over, rules over, refractive index over, power of lens over, formulas over. Okay, so I think you hope understood. So thank you for listening, children. If you like, please share and subscribe. Thank you.